Okay, so in the previous class, we had discussed about Hive and so the architecture of Hive. How do you create an internal table? How do you create an external table? Okay, and why exactly it's beneficial to create an external table. So we discussed that it's better to create an external table because if by mistakenly somebody deletes an external table, the location where the data is stored uh, that still remains intact so that you can recreate uh, the accidentally lost table, and you still won't be able to lose the data into it. But the case is just opposite with an internal table, wherein if we delete an internal table, it deletes the associated data directory, which is by default in the user Hive warehouse, followed by the database name, followed by the table. Okay, so that was about the basic part of Hive. Now today we will talk about few more tables which you must understand when dealing with Hive. Okay, you guys can practice it on your own clusters. I'm having some issues with my AWS, so my cluster is still not accessible, but um, the commands would remain same. You can try it out on your clusters and you can give me the feedback if you're facing issues with it. Okay, so up till here it was pretty simple creation of table. Okay, we were just providing we were using this kind of a statement to create an internal table, and to create an external table we were doing uh, okay, I didn't mention the command for external table. Let me just mention that also. So for external table, this command has few more parameters added. So you specifically mention whenever you're creating external table that this keyword as external. Create external table followed by the table name. Rest will remain same. The only thing this time added is that you have to specify the location where you want to store the data. Previous class, I think we were using /temp to store the data. /temp/ let's say employee to store the data, and so once you specify it, the data will always be redirected to this directory. Okay, okay, give me 1 second. Okay, so we have to specifically mention external keyword, and then we have to specify the location where we want to store our table. Okay, so that was about an external table. Now let's come back to a more advanced table which is called a partition table. So as the name suggests, a partition table is a table which has partitions in the location. Okay. So in this location, when a table, when the data will be added to it, it will create partitions, and that partitions will depend upon, or they will depend upon how we want to classify our data within a table. Okay. So you can think of partition as directories. Okay, these directories and its naming will depend upon how we want to classify, how we want to segregate our data basically, and this will classify our data within separate directories or partitions within the location. Okay, and that classification will depend upon the columns. Okay, it can depend upon a single column, it can depend upon multiple columns of the table. Okay, so for an example, I have here mentioned the creation of a partition table. Okay, so first of all, what is the syntax? Now this time I'm creating an external partition table. You can also create an internal table. So if you remove this keyword, that is also fine, but this time then the table will be partitioned within the default location of Hive, and if you try to delete it, the table will also get deleted. Okay, so if you look at this syntax, this is an external partition table, so rest is quite similar to an external table. So create external table. This is another keyword you can use with while creating a table. This can be used not just with partition table, but with a normal external table like this or some other table. Okay, so it specifies that if this table name is not existent, then only one needs to then only one the Hadoop, the Hive should create it. Otherwise, if table is existing, it should not be overwritten. Okay, so it says create external table if not exists. This is the table name. First of all, this is the database name followed by the table name. Okay, if you are already there in the database, I think I told you last time also, the command to enter a database is use followed by, let's say this is your Hive shell. Okay, let's say this is our Hive shell. So command to enter a database is use followed by the database name. So in here my database is, let's say, Hadoop B9. So I would say use Hadoop B9. This is important to put a semicolon, otherwise your command will not be considered complete. Okay. If you are already in the database, you can skip this part and just mention the table name. But if you want to create a table in a specific other database apart from the one you are into, by default we are always into the default database. Okay. So to use some other database, you can prefix the table with the database name. Okay, so create external table if not exists, database name, table name. These are the columns. So one is an entity ID. I chose one column as ID, the other column as name. Now I have written partition by marks. Okay, so what it means in here that it will add another column marks, okay, to this table, but the data will be partitioned depending upon marks. So what does it mean? So let's say I added few data points to this table. Okay. Okay, I'll give you that example. The rest will remain same. You can see row format delimited, which says okay the rows should be delimited and fields should be differentiated by a comma, and this is going to be the location. Okay. Now let's understand what does it mean by partition by marks. Okay. So when we try to load data, this is a command to load data manually if you want to data one by one. Okay, so it will say load data in path. This is going to be the data within HDFS, and this is going to be the, so we should specifically mention which partition are we adding this data into. Okay, so to give it a more clearer picture of this, so let's say I want to create a table like this, uh, id marks. Okay, this is the data that I want to store. So id1, id2, id3. Okay, id4, and so on. So you have different kinds of different type of data sets. And so on. You have many rows in this table that you want to store. But how would this be stored in a partition table? Because we have partitioned it by mark. Okay, we have partitioned this table by marks, by the marks column. So when you will see this in this location, the data would be stored something like this. This is fine, external. This is my table name. Okay, I'm storing it in temp. Now, the partition will be created depending upon the values of these marks. Okay, so depending upon these values, you will see folders like this: marks equal to 90. Then you will see another folder, marks 91. Another folder, marks 89. Okay, just try it out within your cluster, and you will see that within the location that you have specified, you will see that these three kind of directories or partitions also will be created. And within this partition 90, so right now I have two fields or two rows that has marks 90. So you will see your text file within it. Something like this would be the name dot text, and within that this text file will basically be these two rows. Okay, within this text file only these two rows or these two data points will be present. Similarly for 91, you will see these two rows present, and so on. So your data is basically segregated into directories within the location of the table, and such a classification of data is called partitioning in Hive. We have divided data into partitions. Now, what is the reason? Why are we doing it? Okay, what is the benefit of such a thing? So what happens is, okay, before we just put it, let's talk about partition, but like benefits a little later. Let's first understand how exactly you can load data like this. Okay, so up till here we had just created the table. Now there are two ways you can load such a data. Okay, one way is you specify, so let's say this file that I want to upload to my table, this file contained these two. data points, since it's related with the marks equals to 90 partition. So I just added these two lines, these two rows in this text file, and I just uploaded it. Okay. So the command to manually upload such a file will be load data in path. This is the path. So you must upload this marks 90.txt to the temp. Okay. So let's say if we created this file, you will first upload it with the HDFS dfs-put command. Okay. This is the file that contains these two rows, which has marks 90. I will put it into temp location. Okay. Once you did do that, then you have to enter the Hive shell to run these commands. Okay. So in the Hive shell, you will run load data in path. You will specify the path. Since I uploaded this file to the temp location, I have specified /temp/ the file name. Then overwrite into, so I want to overwrite the data within this table for this partition. So I will say overwrite into table. This is my table name. Okay. And this is the partition I want to create, which is right now marks 90. Okay. Basically, this file will be present in this location. Okay. So this will automatically create this directory and upload the data from temp to this directory. And since it's a classification of marks equals to 90, that means it contains only data points which has marks columns value 90. Similarly, if you want to load data for 91, you can create another file 91. You have to put it to the HDFS location again. Okay. You have to put it to the HDFS location again, and then you have to specify while creating, like loading this particular file into your table, you have to specify partition equals to 91. Similarly, you can do for 89 and so on. Okay, so depending upon what data you have, you will specify it by loading, and this is the manual part. If you want to load data in manually, you can do it like this, or the other way around. Other way around is you would want, and which is a better way, because in here I should understand, let's say if there are millions of records, I should know what those million of records, how many like people have scored 90, how many people have 91, 92, and so on. No, I cannot directly ingest the data within my table without knowing the contents of it. Okay. But let's say there is a situation where we are loading data from an external database, some other database into Hadoop, into our Hive. So we might not be aware about each rows of that data, right? So in such a situation, I would want that while I am ingesting the data, my Hive should dynamically or should automatically determine what directories, what should be the partition like this. So I don't want to specify this partition every time I'm loading the data. Instead, I want Hive should automatically understand, depending upon the values of this column, that what should be the partitioning column. Okay, it should automatically pick up. Okay, so then it's trying to put this line, it will pick up. Okay, I have to put it into marks equals to 90. Similarly, for this line again marks 90. For this line 91. So it should automatically determine sorry, it should automatically determine what should be the partition's value and which lines, which rows should be placed into which partition. So to do that, Hive has a preset or some properties. So number one property that you must set. So all of these has to be run on the Hive shell. Okay. So first of all, I will set this property Hive execution maximum dynamic partitions per node equals to 1000. No need to go much deep into understanding these properties, but yes, you should know that there are certain properties which we should enable before we try to put in data dynamically. Okay, next is enforce bucketing. This is basically dealing with the bucketing concept, and so like these two properties are dealing with bucketing concept. I will explain it little by in a short while, but it's better to enable this also. So first of all, bucketing is equals to true, and the other one is dynamic partition mode should be non-strict. You can read about this property. This is a little good to understand. So there are two modes basically. One is non-strict, other one is strict. Okay. For this case, we will let it be non-strict partitioning mode, so that we don't have to specify every time, but it will automatically pick up. Okay. So to load data in a dynamic way like this, we have to create a temporary table between. Okay. So let's say this same data sets now I want to load in a dynamic manner. So I will first of all set these properties. Once I have set these properties, I will create a temporary table first. The temporary table, you can see it's a very basic table. It's an internal table, and it contains the three columns that I want to load within my partition table. Okay. So it contains the ID, the name, and the marks columns. This is the table name. The rest, it's an internal table, so data is present in the user Hive warehouse location only. Okay. So once I create this internal table, I will load this data into this internal table. So it's very simple. I will just load. You can even place this whole thing into a single file. Okay, let's say instead of putting it in two separate files, I have this data in one single file called marks.txt. Okay, all this data is present in that one single file marks.txt. I will load it into the temporary table first. Okay, you can see it's just a very simple load. I don't need to specify the partition, just single file which may contain millions of records also. I have loaded into this temporary table with one single command. Okay, now once we have created this temporary table and loaded our data, now we will want to load it into the partition table. So what we will do is we will use this temporary table and we will insert the data of this temporary table into my partition table, which is this. Okay, I will use this internal table. So the command now will be insert overwrite table. That means I'm going to overwrite into this table and I am going to partition depending upon the marks column. Select ID, name, and marks from temp. So this is basically a select query. At the end, you are using that select query to filter data from temp. Basically, bring these three columns value, which is basically the complete table itself, from temp, and you are partitioning that data depending upon marks, and that has been overwritten into your dynamic partition table. Okay, this is the only way. If you want to do dynamically, you have to create a temporary table first, completely load the data into the temporary table, and then load uh, using the insert override command from this table and specify the partition. Okay, so this is how you load data into a partition table dynamically without, you can see I haven't specified this time what should be the partitions value the way I was doing here. I just specified that once we are selecting the data, make it partition depending upon the marks column, and it will automatically pick up the values and create directories for create basically partitions for. Okay, so this is how you load. So this, as a Hadoop admin, you might not be given this job of loading data. Basically, you know, this is a developer's job. He will write down scripts and jobs which will automatically like load data on a daily basis. But you should be aware about it, because if something fails, some issues pop up, then you are the one who will troubleshoot it and help you understand. So it's always recommended to understand what is partitioning, how it works, where you can see the location and stuff, so that it will help you out in your troubleshooting. Okay, now let's talk about what are the benefits. Why are we creating a partition table? Okay. The number one benefit will be your results will be fetched in a better or quicker fashion as compared to a normal table. Okay, so let's say I have 1 million records. Okay, in this partition table, and I have around 28 partitions. Okay, and let's take an example of this temporary table only. So it also has the same data, right? So this temporary table also has this 1 million records. The only thing is, uh, now right now, and okay, and also the same data is in temporary table which I created for loading data into the partition. Okay, this is an internal table. It can be an external table also, but right now it's just an internal table. Okay. Now, what is the difference if I run a query like this? Select star. Star means select all the columns from temporary table first, where marks equals to 76. Okay. So there are 1 million records. So, and I have to only find those lines which has marks equals to 76 from this table. What this command will do on Hive part, on the Hive execution engine, it will go one by one on each line or each row of the temp table, comma, compare its marks and only return the value where marks equals to 76. Okay, so for each 1 million row, it will traverse each row one by one. So it will go 1 million times over the data, and then it will compare it and return it to me. So we are actually doing two additional steps. We are going one by one on each row, and then we are comparing it with the marks equals to 76. So definitely this will take much time. Many it will be a cumbersome process, and time taking. So you will get results after a certain amount of time. It could be in seconds also, but that is also a little more when it comes to running thousands of queries. So we want to save our time. This is just not the better way. That's why now when we do some same thing on a partition table, let's say I run the same command this time on a partition table. Okay, how is it beneficial now? So my Hive execution engine, the Hive execution engine already knows that to search for data with marks equals to 76, there is a separate column, there is a separate directory available, right? So it will automatically go, it automatically fetches all rows from that partition. Okay, so it will directly go to that partition marks equals to 76, fetch all the rows and return it back to the person querying this command. So it has saved time of execution because right now because now it will not traverse each row, neither it will compare the marks column. Okay, so these two additional steps are prevented when you are running a search query, and that's why it will take less time. Okay, it takes much less time than querying a simple external table or simple internal table. So what are the benefits? If now I say, so my queries are faster and my search is efficient. Efficient in how way that now I don't have to do the additional two steps of traversing each and comparing. So these two extra steps of execution, they are prevented, and that's why my search is also efficient. These two are like broad, like the much broader benefits you can think of. There are some more benefits uh, which we will understand once you start using such tables. Okay, let's. So this was about partition table. Any questions, guys? Anyone? Okay. Uh, what generally you will see in organizations is that for each table, which is a partition table, you will see that the tables will be having partition depending upon the current date. And why so? Because we want to differentiate, we want to segregate data based upon the date it was ingested. Okay, so depending upon each day's job which loaded some data into the table, I will segregate them depending upon the date value. So you will mostly see that partitions are dependent upon the current date or the date when the data was loaded. Okay, now let's move on to another additional concept, which is like I can say it's we have appended another concept called bucketing within partitioning. Okay. Such a table can be called a bucketed table. So what bucketing is basically that you have further classified the data within a partition. Okay, so this is important to understand. Now, up till here, we were partitioning depending upon, we were classifying depending upon a partition. Now, what about within this partition where marks equals to 90, I want to classify data further. So let's say within this partition, I want to classify uh, only those person whose names start with SAH. Okay, so only one row will be selected. So within a partition, if you want to classify data, you will use the concept of bucketing. Okay, so in here I have taken another example. Uh, so this time my tables contain, let's say I want to load data like this. I have table with columns name, sorry, ID, name, age, gender. Okay, any employee you can put in any information. Similarly, you can have multiple data points, billions of rows, basically. Okay, so you can contain multiples of such things. Now I want this to be an external table. I will say this is my table name. I only specify the name, ID, name and age columns because I want to partition this table based upon gender. So basically it will create two columns of basically three columns which can be male, female or others. Okay, so I partitioned it by gender. Now I want to cluster. So within a partition, I want to cluster it. Let's say uh, instead of name here, it should be age and name here. So I want to cluster this thing depending upon age. So within a partition, all those people who have age 34 or all those people who have age 28, they should be a clustered within a cluster. Okay. So all those males who have age 34 should be within a cluster. So that basically we are classifying data within a single partition, right? So I will say clustered by age. Clustered by age is basically we are specifying the bucketing concept now. So within a partition, I want to group similar age people and I want to sort it by name. So once I group it, I want to sort basically alphabetically by the name. Since I have sorted by name, I want to sort it alphabetically by name into three buckets. Okay, you can specify more buckets as well, and rest is similar to the other tables that we created. The row format delimited, fields terminated, and locations. It's an external table. It can also be an internal partition bucketed table. You can remove this keyword and the location, then it will be basically a partition table which is bucketed by age or clustered by age. Okay, I right now, as I told you, I don't have my cluster ready, so I'm just showing you these commands, but you can run it on your own clusters, and if you feel any difficulty, I will show you by running it on my cluster. Okay, so now when it comes to putting in data into a bucketed table, it should always be using the dynamic method I described here. Okay, When you are creating a bucketed table, you cannot load data in a manual fashion like this. It's compulsory to use this thing. And these two are the additional properties. So I have to enforce bucketing equals to true, and I have to make dynamic partition non-strict. Okay, these two I think are dealing with bucketing concept here. So you must at least enable these three properties before loading data to a bucketed table. Okay, so again I have created a temporary table and I have loaded data into the temporary table, and from this temporary table then I have loaded the data within my bucket. Okay, so these are the concepts, I would say, the Hive advanced tables one must know about. If you want to describe a table, I think I gave this command earlier also. To describe, so let's say I have few tables available already in my database, but I'm not sure what kind of data tables those are. So I can use a command called describe formatted. This will not only give me the table details, the columns, but also to give me the information about when the table was created, how many columns and all stuff, all like all the detailed information about my table. So describe formatted followed by your database name followed by a dot your table. This will give you information about which table, whatever table you can see in the database. Okay, so that's all about Hive and how we are giving a structure. Now there is one more service called Impala, which is similar to Hive. Okay, it's 90% similar to how you run queries on Hive. You can run similar thing on Impala also. But what is the 10% difference is that Impala will make your queries even faster. Okay, even so when you run this query select. So when I say queries, right, mostly I'm talking about select queries. So when I run queries like this on Hive, let's say this is taking around 10 seconds, even if the table is partitioned, although it won't take 10 seconds, it will take around let's say 1 second or 1.5 second. Okay, even if the table is partitioned. But when it comes to running this query on Impala service, okay, so in your cluster, if you are not able to see Impala, you can add this service from top right. Okay, from so just like we have added another service, I think we added Hive this way. You can add Impala service also to the cluster, and you will see that such select queries will, if it's taking 1.5 seconds, it will take half of time when you run the same thing on Impala. So what extra is Impala doing? Basically, if you, I have already created this architecture. So Impala has these three components: Impala daemon, Impala shell, and then you have this Impala catalog server and Impala state store. No need to understand what exactly is happening within these components, but you can see it's then these three components is interacting to Hive only. It's contacting Hive server 2 and then it's contacting the Hive metastore. Okay. So what this Impala is doing, it is storing some additional information, some additional data about each table. Okay. So Impala will whenever we will query some table on Impala, it already has information about that table. But when it comes to Hive, whenever I will query something onto a table, it will at that point of time calculate all those information points, and that is where the time is being spent. So Impala is a way ahead than Hive. It will already store some metadata about each table, and it will store it into these two daemons, catalog server and Impala state store. Okay, about each table of Hive, so that when I run a query on Impala shell, so right now over here I was running on Hive shell. Impala will have his own shell, which you can launch with this command. This is going to be your IP of the Impala daemon. Okay, once you install Impala. So once you launch this command, you will enter the Impala shell, which is connected to this Impala daemon. This is my Impala daemon. Okay. When you install service, you will add at least one Impala daemon apart from these two. So you are connecting through Impala shell to this daemon, and you are running such commands. So commands will remain same. All the commands that we ran on Hive, all of these commands, they are going to be same for Impala as well. But the only difference is Impala is already calculated some statistics or data about each table, and it has stored it, so that when you run a select command on Impala, you will see that it will run pretty much faster. Now, what if you want to, let's say if there's a new table created in Hive and its statistics are not yet available to Impala. In that case, on the Impala shell, you can run this command, compute stats. Let's say this was my table. Okay, let's say this was my table, and I want to compute its statistics for Impala or its information. So I can run this command, compute stats followed by the table name. And if I want to check what all stats are available, I can run show table stats command. Okay. Just try out these commands also. Once you have completed working about Hive, try out these commands and you will see what are different kind of statistics that are stored in Impala, and that makes the query pretty faster as compared to Hive. Okay, so that's that. I think that is all when it comes to Hive and structured databases, structured tables within Hadoop. Okay, and most probably you will be either using Hive or Impala, and the rest commands will remain same. So command to create, load, that will always be same, whether even if you use Impala or Hive. As an admin, your responsibility is to take care of all these daemons. Everything should be working fine. Impala daemon should be up. Catalog server should be up. Similarly, Hive server and Metastore. All of this should be working fine. That is all. We as admins, this is our responsibility. Okay, so that is all. I have written some exercises for you, which you can try out. Okay, and I want you to create these tables. So let's say the first part is basically of creation up till here. Uh, so you have to define like your own table. So you have to create a normal table, load data into it, and then run a select query. Okay, and note of the time. How much time will it take for a normal table? How much time will it take for a partition table? How much time does it take for a bucketed table? So you can compare those timings, and that will make you more understand what in terms of querying it. And also you have to do it from Impala.
Okay, Mr. Sahil, if
Yes, go ahead.
this is Asad here. I couldn't practice even the last couple of classes, couple of things, because of, you remember when I reboot my cluster, I couldn't create again. I'm still I was stuck on the beginning position actually. So could you please check that why I can't go over?
Do you have your cluster right now?
I just create one, but it's not working.
No problem. Let me help you out after it. Okay.
Please, thank you.
Okay. So I think that is all from Hive. Now in the next class we will be starting with a non-relational kind of. Up till here it was all relational. You can see everything was in tabular, and even the storage was in systematic way. But there is another service in Hadoop called HBase, which we will talk about in next class. It is also called NoSQL database. Okay, so we will talk about this service in next class. Also, I am planning to take a test for all the concepts we have covered so far. So your Linux, basic Linux, your HDFS, Yarn, Hive, and most probably HBase also. So I will create a test that you can take depending upon your own timings in the next week, and that will check your understanding of these concepts. Okay, so make sure at least by next Thursday, or I think I will post it by either Wednesday or Thursday, that you have at least covered the concepts so far. Okay, okay, Isa, I will make you the presenter now.
Please.
Yeah.
So I have a quick question. So you said you're going to be sending out the test for us to do on our own
Yes. So it will
to
be
make sure we know
a
the
choice.
concepts.
Yeah, it will be a multiple choice test. Okay, it will have some questions. You can take it on your own timings, and I will have the results once you complete it.
Okay. Okay. Thank you. Is the class over?
Yeah, class is fine. If you want to leave, it's fine. We'll just be
Okay.
troubleshooting ASAR issue. Yeah.
Okay. Thank you.
Yes, ASAR. Tell me.
Yes. Okay. I just made one node here.
Okay.
Then I just connect here. But I maybe I have downloaded the repo file, but I couldn't connect in a web browser.
Okay, let me see.